in New York. Oh yeah, good idea. Yeah, so when I was at the AI Engineering Summit in New York at the Anthropic workshop, they were talking about MCP, and they kind of talked about where they hope MCP develops in future. And one of the areas was like for multi-agent systems, and using agents as MCP servers. And they even showed Sarmad's MCP agent framework as well, and said it was a really good example of an agent framework that makes use of tools as MCP servers. And so when I got home, I dived into MCP agent and saw a bunch of like parallels with what we had been working on with NAPTA, which is this kind of like interoperable agent framework. So the cool thing about MCP agent, for example, is that the different tools could use different like agent frameworks, or they could be even like written in different languages because they're all MCP servers, right? So it's like a good example of an agent framework that has like these interoperable tools. And then I reached out to Sarmad and said, are you thinking about agents as MCP servers? And he said, yeah, I'm like working on an example, and he shared the code with me. And so it seemed like there was a bunch of like overlapping interest in the direction that both of our SDKs were going. And at the same time, I dropped into Sarmad's Discord server in the MCP agent channel. And I think I was like the first message. And like one of the things we talked about on the call was basically like, how do we build this community of people that are working on not just MCP for tools, but also MCP for agents, MCP for like multi-agent systems, and who knows, maybe MCP for other things as well, like environments, knowledge bases. There's like a bunch of stuff that we could explore here. And so one of the ideas that we had was, why don't we host like a joint call with both of our communities and post on Twitter, and yeah, just start to build this community of people who are working on things like agents as MCP servers or MCP in multi-agent systems. And so yeah, this is the first one of those. And yeah, hopefully we can like, I don't know how many people here are building like agents as MCP servers, but what we want to do here is like some sort of knowledge sharing. Like maybe people will share some code or demos. I know Sean, for example, said he wants to demo something when I chatted to him earlier on. So that's at least one demo. Sarmad, I'm sure you want to share some of the stuff from MCP Agent, and anyone else here who has like built an agent as an MCP server or has any thoughts about how to do that, or like best practices or things they're stuck on, like what do we need to work on to make this easier? Like hopefully we can discuss all of these things in this call. I don't know if you've anything to add to that.
No, I think you had a great overview, and I just wanted to also congratulate everybody for being early on the MCP train, because I've been starting to talk to a lot more enterprises as well, and it's really is taking off. People are very interested. There's a lot of groundswell momentum around it. So I think I'm very personally bullish on the protocol helping the entire industry kind of standardize some really interesting patterns for how you build agents for production. We're starting to see that, like there's Cursor and Claude Desktop and Windsurf and a few other clients that support MCP natively, but I think it's just the start. And so just in a few months' time, I think the AI developer community will look very different, and how we build AI applications will be very different. So thanks for being early on that. And yeah, I'd love to just keep this very casual, just demo based. If folks have questions, we can like brainstorm and talk about it together. And like I think Richard said earlier, there will be more of these. This is just the first iteration. And so just give us feedback as well on what you'd like to see going forward. And with that, maybe I can pass it to Sean to get demos started. And if folks have demos, just like either raise your hand or message in the chat, and we can like go in order of the messages, perhaps.
Okay. All right. Let's see if we can get this working. So what I'll do actually, I was going to kind of show the data analysis tool that I bundled as part of an MCP agent derivative. So let me just share my screen, make sure I'm showing the right window. Hey, can you see that?
Yep.
Okay, right. So so I've just set my API keys in a new terminal window. What I'm going to do is let's create a new Python environment. And what I'm going to do is I'm just going to get us started with literally just running a very, very simple agent with a single MCP server attached. So let's say uv pip install fast agent MCP. So this is basically MCP Agent with a bit of a front end put over it and a couple of other under the covers changes. So that's installed it. And if I then just say fast agent setup, say yes. So the first thing I can then do is just say uv run agent.py and fingers crossed. Yeah. Hello, good evening. And I can, yeah, send a message. In this case, the default is to Haiku, and we can see the fetch MCP server is there ready to be used. But what I think we'll look at is a bit more of a detailed example, a bit more sophisticated. So what I'm going to do this time is say fast agent bootstrap data analysis. So just while I'm doing that, are people kind of familiar with if you've used ChatGPT, if you're familiar with its data analysis tools? So where you can upload a file that's bigger than the context window, and it runs a Python interpreter and tells you a bit about the data. So what this example does, so if I just now go into the data analysis folder, so what this example does is it uses MCP servers to achieve the same effect. Okay, and it also demonstrates the use of an MCP server feature, a client and server feature called routes, which isn't particularly well supported in a lot of places yet, but this is a good example of where we might want to use the routes feature. So I'll open this up in VS Code in a second as well, so we can have a better look at the folders. So what happened when I created that data analysis was I've got a I'll open that up in. So it's got some MCP servers defined. For this demo, we'll just leave the Docker server on. And I'm just going to show you the agent code here. Oops, need to do that. And I'm going to just get rid of the second step. So all we're doing here is we're defining an agent, giving it an instruction which says that you do data analysis. We specify that we're going to use that Python interpreter. And then we give the agent an instruction. There is a CSV file in the current directory. So we don't tell the agent what the data content is. Okay, there's just a CSV file in there. And we'll see if the LLM can figure out what to do with that. So let's fingers crossed Docker is gonna run properly. Let's have a yeah, I think that's starting up. Perfect. Okay, so we're now doing that. So it's now using I'm gonna keep on saying that one, MCP server, and we can see that it's calling the interpreter with its execute Python, and it started to actually interpret that data. So what I'm going to do now is open that folder up in VS Code. Just we'll let that run. Again, if anyone's got questions about this while I'm doing this, then just shout out and I'll answer. We can look at a bit more of the detail if necessary. So we'll just let that run for a moment more. Do you remember what I called that? What I called that folder? Was that temp1? Don't think I
And it
can
looks like
remember
it
what.
also is like running in a loop, right? So it said I need to import NumPy, so it's like fixing its own errors as well as it goes along, just like code interpreter on ChatGPT.
Yeah, absolutely. Yeah.
Very cool.
Sorry, yeah, I
There's
think I called that temp1.
analysis.py agent, or is it using the agent? Which I guess like a question on how you wrote how you implemented the agent itself.
Yes, let's take a quick look at that. So I'm just gonna bear with me while I open up a new VS Code window. I think it's the easiest thing to do because that's causing a Yeah, so in this case, I just ran analysis.py. So let's bring connected WSL folder tab 1. Okay. Right. Okay. So that's now finished its analysis. I'm just going to give it one more command. So what I'm going to say is, can you summarize that into a final markdown report, incorporating visualizations that best describe the data for a human. Okay, so I haven't actually attached the file system services, so I think that will probably just do that through the Python interpreter. And I'm going to now, that'll run in the background, and so I will now open up that in Visual Studio. So where's my share button? So again, right, it's kind of super easy to build out even a quite complex workflow and just give it a couple of prompts. And all of this is done entirely with MCP. So where is there? So I'm going to stop the share there and share in VS Code or
And
symbol.
is the agent itself an MCP server here, or mostly the tools?
No, so it's using the tools as an MCP server, but I do have a branch where you can start it as an MCP server as well, which worked quite well actually. I was struggling a bit with the inspector tool. That seems to be a little bit yeah, a little bit flaky actually for testing SSE and standard IO servers. But yeah, it was yeah, so we can run that as an agent just by flipping a command line switch. So yeah, the agent definition is here. So we've just got a very basic prompt. Again, it's not particularly tuned. It's just a kind of out of the box demo. And then this is the initial prompt, which then produces the output. Should we see what it's done? Right, I think that's probably most interesting. I don't know what it's done. Okay, so look, it's produced a whole load
Wow.
of data here. And again, you can follow along at home with this quite easy, right? You can produce the exact same thing. This is with Sonnet. We could run this with O3 Mini by just changing a command line switch, right? We can add, for example, another agent. So I've done this. I mean, for time, I'm not going through it all. But for example, it's quite easy to add another agent which does a Brave search and does a bit more exploration around the data set, so that the report it produces is is a bit more useful. So I don't know if it did actually emit a markdown file. I'm going to
Looks like it
just
created
tell
a
it.
CSV. Um, the WAFN, like it's a fifth from the bottom.
Oh, this one? Yeah, that's
Yeah.
the input file.
Ah, that's the input. Okay.
That was the input file. Yeah. Yeah. Do you know what I'm going to tell it? I'm going to just say, can you markdown report?
That's really
Updating.
cool. It generated all of that analysis from a single prompt.
Yeah, yeah, yeah. Yeah, exactly.
And
And because it's so easy to kind of attach other MCP servers and to hook them up in either a chain or with a router or some other workflow, you can start to build. So a kind of more advanced example of this, it took about 20-25 minutes to run. Actually produced a kind of social media campaign in 3 languages for 3 platforms, kind of based on the insights from this data. And the thing is, obviously I've started with those prompts, and again, it hasn't been primed to know that it was this employee attrition data. So I've got exercise data and a whole bunch of other data sets, and of course, just using MCP and a couple of basic prompts, it's very quick and easy to get this stuff working.
So when you say, so I saw you just use natural language and you were very brief. And when you say MCP took like handled it for you as far as a tool user, you are you familiar with like this looks like it's using like Python's like libraries to create charts and stuff. Are you
That's
familiar with
right.
what
Yeah.
the code is doing? And
Um, so
like
how's
can we introspect um the script that it generated before like while it was
yeah.
producing this work?
Yeah, you can. Yes. Let me just go back to the other window quickly. So the way I've got this set up at the
We,
moment is
by the way, Sean. Oh, there we go.
yeah,
Okay.
yeah,
Well,
So but the way I've got this set up at the moment is that we see the tool calls are in magenta. I trim. I'm actually trimming the outputs here for display purposes. So there's a setting that you can just say, which is don't trim the tool call. If you switch on logging, you'll get a JSON-L file, and the JSON-L file contains the whole thing, right? But you obviously need to unpack that. So yeah, you can review it. I again, I've experimented this quite a lot. If there's some code at the bottom that's commented out, which runs this with an evaluator optimizer. Sonnet 3.7 is a bit weird as an evaluator optimizer. It tends to over plan. But I have also seen it write code to check its own code. So if you kind of if you leave it in a loop, if you've got enough token budget, it will do that. So yeah, I mean,
Okay.
obviously
That's a good
Python code.
answer. That's a good answer so far, but like could we have a repo generated that like a Python developer could review and like look at like as another asset of this pipeline?
Yeah, I'll tell you what. I mean, let's try it. Okay, I'm just going to say, can you emit the analysis code as .py files in the current working directory? Now, I don't know if I would fully trust this at this point, but it would be so as part of building an agent pipeline. If that was what I chose to do, I could prompt it to produce the data analysis code and then have another agent then execute that code.
mhm.
So that kind of division of responsibilities in a multi-agent system is actually quite easy to do because using these types of frameworks, it's really easy to get the agents to share data. You can prompt them to share data across the file system or a database or some other storage. If I mean, something which I'm starting to incorporate and getting quite a bit of value out of is actually using Git to version control certain things. Uh, so again, because most ELMs know very well how to actually use the tools, and there's just really
Yeah,
a case of figuring
I
out how
would
to do.
hate to be consuming the GPU when we don't need to. Like if we can create the tools once, might as well create them
Mm,
once and not have to have this whole operation happen. That could actually change. You don't want it to change for science reasons. Like, yeah. But this is
yeah.
great so
We'll
far.
see.
Thank you
Yeah,
for
yeah. We'll
sharing
see.
so
Yeah,
far.
yeah. No, no. We'll see what we'll do. So look, what I'll also do is I'll just quickly show you. Let me. So actually, this is an earlier report, but I'll pop this on the screen as well. So I'll just show you the config file, right? Because I think that might help explain it as well. Um, so I think do I need to shop? Yeah, I need to stop share and then reshare, don't I? So let's do. So, yeah, so
You
there's another kind of earlier report, right? That we run, but yeah. So with that Python interpreter, this is this is how the roots works, right? So I'll just quickly describe why it uses roots there, and then we'll talk about what else we could bundle with that Python interpreter. So so what we're doing here is we're configuring fast agent to say expose this route to our MCP server. Okay, and so what we're actually doing is we've got a local mount point, an alias that we then use to tell the server that, and then in our Docker command, we're actually mounting that folder. So the powerful thing about that is in a multi-user environment. So imagine if you're in a hosted chat environment or in a multi-agent environment, it means that we can prompt and script our agents to say, well, look, you always see files in your /mount/data file directory, but actually uploaded data from particular users or from particular environments can be sandboxed, right? So Roots gives us a nice consistent way to present data to an MCP server, so we don't need to configure it every time. And it gives us a way to kind of sandbox and isolate various other bits. So there's a GitHub repo which contains this interpreter. So one of the things about this kind of data analysis tool is because going into it, we didn't know the shape of the data, right? So it uses the Python libraries to figure out the shape of the data, and then it produces custom code based on that data to then figure out, oh look, there's a working years correlation or something quite specific. So if I already know the shape of the data, then yes, I can bake the code once. I could bundle that code as part of my Docker image if I wanted, and then instruct the MCP server to use those scripts. But obviously, with the tool as it currently is, the first thing it does is actually figure out the shape of the data, and then based on that, and then based on the shape of that data, it then builds the appropriate programs to analyze it.
Sean, is this using O3 Mini High? Is that what you have set the LLM to, or was it Claude in this case?
This is Sonnet 3.7.
Okay.
I can do. Should we do a run with O3 Mini? We can. I mean, if someone else wants to kind of do another demo, I can run it in the background and we'll see what O3 Mini does. I tell you, Sonnet 3.7, I think will win this one hands down. But
Well, I see the markdown file as well now, by the way. It's like the 5th on the list. I guess this is the final analysis that is produced.
yeah,
You think? Nice. That's really cool.
yeah, it's super. And again, I mean, one of the it's not really for show today. Maybe someone will want to look at it in the future, but it's some fairly sophisticated. I don't know if anyone uses MARP, the Markdown presentation format. I mean, there are some beautiful styles for that that you can then use to produce some very, very polished outputs.
One
Have
thing I
you
did
tried?
want to call
Oh,
for
go
demo
ahead.
is the roots feature that you pointed out. Like I think almost all MCP servers that I see so far are just like tools. And so effectively like there's nothing new compared to like Open API, even though MCP itself supports so many more capabilities. And I think Roots is a really, really great example of like how you can do very sophisticated things in addition to calling tools, which is like the base building block of all this. So it's really,
Yeah,
really cool. And you added this feature to MCP Agent and to Fast Agent. So it's I love like just leading from the front on that.
yeah. Well, do you want to see the prompts, the
Yeah,
prompt
that
stuff
I
that
think
we added? Let me. Yeah, I don't. I mean, this. I don't know if everyone's following along. If this is boring, is everyone dropped or what?
no, there are plenty of
I've just been kind of like talking
This is
into the
great.
mic. Yeah.
going.
Yeah. Okay. Let's just take a quick look at prompts. In fact, let me do that back from the console window.
I enjoyed your thread about prompts on Twitter, Sean. I didn't know too much about the MCP prompts. It was really helpful.
Yeah, that's. I think there's a lot I want to do with prompts for what I'm building next. So, yeah, it's. So I can't remember what I was doing here. This is quite brave for me to be navigating around like this. I reckon this will probably just work actually. Oops. So yeah, let's see. I can't remember what state I left this demo code in, but let's see what happens. In fact, I'm gonna reset UV. I think let's Probably a spin activator. So, right. Oh, actually, that's an MCP server. I was running the wrong thing. Okay, so yeah, let's take a look at this. Cool. Right. So yeah, this is quite interesting, this one actually. So what we've done is we've added prompts functionality, so I can list the or apparently I can't. So it's loaded some prompts. In this case, we've done some in-context learning, right? So the prompt, if I remember for this one correctly, is around returning the sizes of objects. So if I do the sun, yeah. So right. So let me just quickly explain the setup here because that probably didn't make a lot of sense as to what happened. So I'll start right from the start. Let's take a quick look at the code here before we go any further. So this sets up two tiny agents, okay? Both agents are given a very simple instruction to start with, which is given an object to return its size. And I've got GPT-4 and Haiku as the models. Okay, I'm going to just going to comment the MCP server out there. Okay, so sizing setup is an MCP server which has got a bunch of prompts in it. So I'm going to get rid of this apply prompt code as well. So await agent.sizer is basically going to open up a prompting interface for me, right? So I can either send it a prompt. I could sort of say, if I wanted to know the size of Jupiter, then I could just say Jupiter and it would run and say Jupiter, but we'll have it open up the prompting interface. Now, when I'm talking to Sizer, I've actually got two separate agents here, and so what I've actually declared is a parallel, right? So when I enter my prompt, it will go to both of those agents simultaneously. And if I specify a fan in, I can do some extra processing. In this case, because I haven't specified a fan in, it just combines the results of the pair and then sends it to the next agent in the chain. So let's just quickly run that. I don't know if someone wants to shout out an object for getting a sizing of.
Empire State Building.
Great. Okay, so you can see it's sent the product. So the reason it's there twice is obviously because the parallel it's showing up on the screen twice. Yeah, so I get two answers. And again, there's no other prompting involved here, but you can see that they've got quite different styles. Yeah. So and again, this is the combined response, which is showing that here was the request, here's the response from one agent, here's the response from the other agent. Okay, so but you can choose to do with that as you wish. So let me just have a look at what we've got in the config file. Right, so yeah, so this is a test file that I've been using, but down the bottom here, I've got two separate agents. And I've got, again, I've not looked at this. I didn't prepare for this demo, right? So I'm learning along with you. So, but in this case, I've got prompt sizing 1.py. So this is the one that we'll play with. Prompt sizing 1.py is, yeah, it's a really simple and fast MCP server. So if you've been looking at the Python SDK, this is probably fairly familiar to you. So yes, the sizing agent setup, we just declare a single prompt, and that prompt responds with a set of user assistant pairs. Yep. So so what we're able to do here is set it up for in-context learning. Yeah. So it lets me say, here is how you should respond to the specific input. Okay. So there's a few reasons we want to do this. Well, let's just run that so that we can see the difference that we had before from the earlier Empire State Building. So we'll get those servers set back up. Okay, so what I've done here, we've attached the MCP server to the agents, our MCP server, which has got the prompt functionality in it. And what we do here is we say apply prompt. Okay, so I talk to the agent directly and I say apply the prompt, and the prompt that we have with sizing agent set up. We always, I don't know why Zoom is requesting remote control of your screen. I don't think I want that. Does someone want that? I don't want that. So, the rule that I've basically applied is that if the last message in the prompt is a user message, we send it off for inference and return the result. If it's an assistant message, so we always make sure that always returns an assistant result. So let's run that. Okay, so what you can see is that it's applied those. It's said you can see it's highlighted the MCP server that it's got those from. Then we'll just do Empire State Building. Then we won't get an identical result, but we will get something which is a lot more familiar. They both come up with the same type of format and answer. So the cool thing about this, right, is that this isn't about kind of coming to a structured output, but quite often, particularly in multi-agent workflows, if we let the agents just kind of be as verbose as they like, then we can end up just consuming tons of context window unnecessarily, right? So it's quite handy to be able to say, given this job description, here are the kind of the 10 main items that are in it, rather than having a kind of quite verbose output. Yep. So there's quite a lot. There's quite a lot that we can do with prompts. I think quite a good way of transferring agent state as well. So yeah, cool.
Super
that was
cool.
prompts functionality.
Sean, have you tried to well, first of all, when you run this,
the reason we couldn't see the prompts from the interface earlier is because I was being not so smart. Yeah, because Parallel, because it's a workflow type rather than an agent itself, doesn't directly support prompts. I mean, that might be something we could think about adding, but so it needs to be something with an LLM attached, so it can use MCP. Yeah, so I think I just can't remember exactly what we were talking about. I think
I was asking about the cursor, if you've tried the agents through that interface.
I haven't actually, no.
It would be cool if you could have the markdown files and be interacting with them at the same time through the chat with the MCP tools. That would be super.
Yeah, I don't know. I mean, my kind of brief survey, I don't know how many tools actually support prompts with user message pairs. I think a lot of them so Claude Desktop just attaches them as a JSON file, which obviously isn't the same thing. But I've not really been testing prompts against the other platforms.
Super cool.
Cool. I'll tell you what, right? I don't know who else wants to demo stuff, but whilst doing that, I will. But so I'll. We did temp 1, didn't we? Let's go to data analysis.
Yeah, and while Sean,
I mean, for anyone that's not done this before, right? It's less than 30 seconds from when I started to actually running an interactive session with an MCP server attached. Yeah, and you can kind of see, right, if you're using Python with that Python SDK, you can create an MCP server. Again, that kind of syntax for creating an MCP server is so small, you can get this stuff up and running and attached, so quickly. 10 minutes, you can have a custom MCP server and client together. So, tell you what, let's move 1 point.
As far as like community helping, is this all open source by the way?
Yeah.
Like, okay, cool. And so is there things that you think the community can help build out, or is it pretty much like done as far as you can see the project? Because like it already does a lot, like it kind of seems to do what it's meant to do.
I mean, honestly, I could keep a team of developers of about 3 or 4 people busy full time for 3 or 4 months. So yeah, if anyone wants to contribute, yeah, please let us know. Yeah, desperate for help. If you want to.
There's currently so Sean has forked MCP Agent, and so there's a fast agent repo currently that has a lot of these really great UI interactive components that Sean has built. And then there's the original MCP Agent repo. Our goal is to like merge those two so that there's like a single initiative going on, and so that's still the goal. There's just a lot of amazing work that Sean has done. There's currently a branch that with the PR out that's like I think 10,000 lines if the last time I checked of diffs.
We'll fix it, yeah.
Yeah, so like we're basically gonna, so that the main repo has a bunch of issues as well. There's also tracing and like evals that I think Russell, you were like pointing out kind of the questions around, how can you observe some of this stuff that's I think important. And then there's also just additional MCP features. So I don't know if we currently support resources, for example. We've talked about prompts, we've talked about tools, we've talked about routes. There's also resources, there's notifications, there's a couple of other MCP features that I think also need to be added to really get the most out of it. The goal should be like support the entire protocol so that you can use any part of it to build applications really easily. And so yeah, there's like a ton that folks can jump in and help out on. And so far, most of the contributions have been from the open source community, and it's going to be an open source project forever, which is I think super exciting. And that's how like I got in touch with Sean. That's how I got in touch with Richard. I think like the frameworks are themselves are less important. It's the protocol that really like matters and how those like protocol enables interagent and inter LLM communication.
Yeah, totally.
Yes.
And one of the things Sarmad and I talked about was merging like what we're working on, which is something like an interoperable agent framework together into one. Because I don't know if we need like two different types, and it would be great to build network effects and all contribute to the same repo, so that if one of us adds something, that everyone else benefits from it as well.
Absolutely.
Yeah. So hey, look, Russell, it did respond to my command to save the Python. So
then instead of trusting the tool to generate the charts, you could just run the tools, generate the charts, and then yeah, you're good to go.
Yeah, it's done it. Yeah, I mean, you can see. Yeah, I mean, to be honest, the code actually looks pretty good. It's better than anything I'd have written.
Yep. Usually.
Genuinely. Yeah. So yeah, you don't need to burn it unnecessarily. All right, so before we hand over, what I'm just going to do, because we might want to just finish off with this, we'll see how it does, is just go uv run analysis.py model equals o3 mini.high. See if that starts. If it does, then we're good. We'll see it. Well, and I'll let you know if it produces any output at the end, right? Yeah, so yeah, it's using o3 mini high.
Amazing. Also wanted to call out like any other discussion points or anyone else who wants to demo. I think that would be, we have 12 minutes left, so would love to just open it up to the room.
I'd love to do a 5-minute demo at some point, just to show some progress we made with MCP. I don't know if someone else wants to go first.
Go for it.
All right, sweet. All right. Can you see my screen?
Yes.
All right, sweet. Yeah, so we have, I guess, just to back up, like we've been working on something we call modules, which is like very similar to MCP servers for a while. And we have like different types of modules. One of the modules is like a tool module, and this is the tool module that we've actually got working with MCP now, and I'll show you it working through Cursor. But there's also other types of modules, like we have agent modules, which look quite similar to what you just saw with Sean and what's in MCP agent. Like we have, config files, and in the config files you define like, which LLM to use and like different parameters. There's even like a schema which is similar to MCP agent, so you can kind of start to see why we're thinking about combining into one. But so we have tool modules, agent modules. We actually have these other things called like knowledge base modules. And one of the things that Sean showed was like storing files to root, which I guess is stored in the file system. And that's kind of like similar to knowledge base modules, except you can store them in a database or in a file system for ours. So one of the things I'm super excited about are these, like, how can we build knowledge bases as MCP servers? And like, what does that mean with interacting through Cursor? Because, you know, it enables, maybe like all of us could be working on Cursor with our coding agents, and all of our coding agents could be like adding information into like a shared knowledge base or into like a shared group chat. So our like coding agents could be running, you know, on our laptops, but then, you know, chatting to other coding agents to get help, or like adding to this like knowledge base, kind of like Sean showed us with file systems, for example. So that's something I'm super excited about. And then there's like a few other modules as well. So this is like kind of how we picture it. Like, we've been calling it the web of agents. So you can like run an agent on one server. It can be using a tool on another server. Maybe it's being orchestrated by another server. And then maybe you have like a knowledge base on another server. And we even have like support for memory modules as well. So you could actually store memory on a different server again. So like, this is kind of the vision for like these multi-agent systems using MCP. But yeah, so back to this tool module. This is the one I'm going to show running. And just one more thing that's important is that so like, our modules don't usually contain servers. And actually a lot of MCP servers don't even have servers. They run in like standard IO mode. So they just like install packages. And that's what all of our modules are like. And so we separate the server from like the application, the infrastructure from the application. And so we have this other repo, which is called napta node, which basically spins up a bunch of stuff. It spins up like an MCP server and other servers like HTTP servers, WebSockets and stuff. It also spins up like VLLM or Olama for local inference, and it also spins up the database. So this is just kind of like packaging everything together. So from one repo, I can like spin up my MCP servers, spin up my database, spin up my VLLM. It also spins up LiteLLM to provide a standard interface, and it even has like a task queue and message brokers and stuff like that. So what I'm going to show you now is we're going to spin up this node repo, which is going to spin up the MCP servers and all of the other infrastructure. And then we're going to go to Cursor, and we're going to run this like echo tool via Cursor, which is going to run on top of this infrastructure repo. And so yeah, I've already started this. This is like in the node repo. All you have to do is like bash launch. And then, like I said, it spins up the database, it spins up the server, it spins up a HTTP server and a WebSocket server, MCP server, spins up LiteLLM, and also spins up like VLLM for local inference, which means, by the way, that you could, you know, make a call to a agent as an MCP server, which is actually using like a model that's running locally, which is super cool. Okay, and then I'm just going to go into my log so I can show you that it's running. Then I'm going to go to Cursor. Not the SDK, so many windows open. Oh shit. Not the SDK. So this is running. I'm going to do a new chat. I'm just going to say use the echo tool. So it's calling the echo tool. And then I'll just show you that it ran here. So it's like running.
Can you tell me what the round trip time is on the echo?
I actually don't know. We don't print out the times here, but pretty fast, I think. Like, it's basically just, you know, a print statement, so there's not much latency.
Well, yeah, that's exactly what I wanted to know, what the minimum floor is.
Yeah, I'm not sure actually. That would be interesting to explore. I can let you know when I can like add in some timers and stuff, and let you know. But yeah, I mean, this is just like a very simple example of just like one of the most basic tool modules with napta working as an MCP server through Cursor. But the next step is to like do more complicated stuff. Like, we have a bunch of agent modules, like that knowledge base module, like getting group chat working via Cursor would be really cool. And then we have like more complicated multi-agent systems that already run across multiple servers, and we're going to set up as MCP. So we've actually implemented like Baby AGI across multiple servers, which is that task solving multi-agent workflow that people might have seen. We've also done the Stanford generative agents, the social simulation paper across multiple servers, so that you could have like an agent running on my laptop, an agent running on everyone else in the call on their laptops, and then all of our agents could be taking part in this social simulation and also be storing the data to another like knowledge base stored in a database somewhere. So yeah, that's the progress that we've made with MCP, and hopefully have more to show next time on the call.
Yeah, and I would just like to add to this that like not just stored on the server, but stored on our own servers and stored on the server and stored everywhere it needs to be. Like the agent, because the agent lives on it can live anywhere. So like this is like how we control it and not like how like the other people control it. It really
So you could
is.
store all of your data. Like you could just be, if you want to use Cursor in your coding, you could be running this like infrastructure on your laptop, and you could be running the LLMs locally yourself. You could be storing data in the database, like to provide context or something like that. So it can be like fully local if you want, and you can also like join these networks and cooperate with.
And the agents are going to eventually start joining networks and cooperating on our behalfs.
Yeah, interagent communication becomes pretty interesting then.
Yeah.
One thing I'm curious about, actually, I think there's no time for more demos, but just generally wanted to get a pulse from the community. There is this big debate going around about MCP, the design of MCP being stateful versus stateless. And currently it's a stateful design, which is unlike how generally like web services are built in like the rest of the industry. And so I'm curious, like, is that a blocker for folks, or how are folks thinking about that architectural divide?
If I may raise an issue, I
Please.
personally see that MCP is great for like a project when it's like just getting started. But like I've been pretty set on using gRPC plus libp2p, and I do crazy stuff like sharing tensors and like training things with Lion AI. I'm not sure if you know who they are, but so I still haven't been convinced that I should migrate away from that. And I had seen something about like the deserialization times being perhaps an issue as well. And like, do you know what mixture of experts is, for example?
Yep.
Like my former junior dev is working with Carmack, and they're doing like these weird model routing things where latency is really important, and you don't even always want to go over the TCP/IP stack, I guess, with some of the MOE things. But trying to keep like latency really low, I think, is going to be good if you want to have like token-wise routing.
Yeah. No, I completely agree. And I think we were talking to a pretty large company, and they had exactly the same feedback for MCP. They're like, it's probably 2 to 3 months away from them seriously trying to adopt it at the moment, just because they also have tons of like they've standardized on gRPC endpoints, and so I think there is like possibility for further iteration. But yeah, completely agree with your points.
I think stateless is on the roadmap for Anthropic MCP. Am I right in saying that?
I'm not sure. I think
I think
there's a very big discussion on GitHub going on at the moment. I'm not sure if it's like committed on the roadmap, but it would make a lot of sense for it to be. Yeah.
I
And I
think
don't
How
see
is
Mark.
it stateful? How is it stateful, like generically speaking?
So it's built on like it's inspired from language server protocol, which was Microsoft's way of standardizing language services. And the way that was designed is you like initialize a server, and then there's like a session state that server has in memory, usually, and then like you send notifications, progress, cancellation events, and so there's like an inherent state that the server has that's associated with the session. That worked pretty well for IDEs because most of the language features are running on your local computer as processes. But obviously with MCP, because it's like, those services can be running anywhere, and they're interfacing with all these like very large service endpoints that are out on the web, it becomes much harder to like create stateful servers. So I think that is an issue in general, but I don't think it's like, for example, list tools can work in a stateless fashion. Like there are parts of MCP that are already technically stateless, even though they're wrapped in this like stateful representation. Um, but yeah, it does require some more thinking. Like notifications and progress and cancellation, those are stateful operations at the moment.
Okay, that's interesting. So I'm joined another community that like so I'm part of a lot of communities. I'm kind of just joining them all lately. And so we do a lot of MCP with naphtha, but I'm also joined this thing called slop, and the way we're approaching MCP is a little different. And it, I guess, is not stateful in that way. Like we don't have any, we are not prescribing like a state machine or any sort of like way these agents should like be doing these transactions. That's up to like the agent to figure out. It's more of like what are the minimum like HTML/HTTP spec that we can use to communicate, kind of like how OpenAI's AI like inference AI is like become a standard, and now we can just use one client to talk to all the AIs. Like MCP should be similar to that, or whatever we're building should be similar to that. Where it's like we could use the old school technologies that have already been existing to communicate over the internet. Like that's been solved. So like if there's a lot of vendor lock-in that's involved in like MCP, like as far as the state machine, that could be a blocker. But like as far as like unlocking all this magic, I think that there's room for like multiple implementations. And in fact, I think that's what we kind of need to happen is we need to have a lot of implementations of like MCP servers and like whatever else just to see how we can compare them. So that's kind of my philosophy at the moment.
No, that makes sense. And just like a very maybe last point here is it isn't vendor lock-in because it is based on JSON RPC, which is also a pretty well established like protocol, communication protocol. But yeah, take your point on things are early. There are lots of like interesting alternatives, and so hopefully we do align on a single way of doing things. I think that'll help the entire industry.
Well, I
But yeah,
guess
thank you everybody for joining as well. Maybe Ben, last thoughts, and then we can end it.
yeah, my last thoughts are like, why did no one go to like the IETF or WC3 with like this proposal for like standardization?
I hope it happens, you know. I think it's just early. We're like moving at the speed of light in this industry. It's crazy how much innovation has happened. And like, I remember even just a year or so ago, tool calls were still kind of new to the models. And so, you know, just establishing patterns for interfacing with the world around these AI systems is a relatively new concept. And a year seems like a lifetime. So MCP is what, like it was announced last November. So it's less than like 4 months old. And so, you know, things are just new. Well, it'll take time, but I think it should be standardized.
I mean, it
Uh,
seems like a lot of the conversations I had when I was working on OpenStack 10 years ago. And I feel like we often find ourselves in a Schmidt-Huber like moment of rediscovering works from decades ago.
oh yeah. I mean, that's true of many more things, especially in the AI space.
Totally. All right. Thanks, everyone. Successful first call, I think, apart from our interruption in the middle. We'll try and fix that for next time. But yeah, great turnout, great conversation. And yeah, looking forward to, if anyone wants to present demos next time, like reach out, I guess, to one of us and maybe let us know beforehand and we can make sure to have some time for it.
Yeah,
But
just
yeah,
find
great
us
to
on,
see the.
and maybe we can like create a small community at some point. But yeah, well, probably Richard and I are gonna try to do this regularly. So thank you for attending.
Yeah, thanks, everyone.
Bye,
Thank you.
everybody.
See you
It's
next
great.
time.
Take
Bye-bye.
care.